If you're interested in the future of manufacturing, then watch this space. Rob, what are these parts?
So this is actually a mount for computer that we designed very quickly and printed using the HP MJF process. It was actually used in the recent Giro d'Italia cycle race, and Team Bike Exchange, they rang us up and they needed a solution very quickly. We quickly got on the computer, and within 3 days we had a solution which was sent out to them ready for the first stage.
3 days, that's incredible. Right, let's find out the process on that 3D printer. Paul, here at 76 Project, you've invested in 3D printers from HP. Why did you go for this technology?
So it took us a long time to find out what was the right process for us. We were quite diligent in testing other processes and parts. We looked at resin-based 3D printing. We looked at other powder-based systems such as SLS. We ended up with MJF because of the part quality coming off. We tested and worked out whether the part costs would be right for us. And some of the part qualities we were getting, like the isotropic properties you get from the HP process, so being equally strong in each X, Y, and Z directions.
So this is the HP MultiJet Fusion. How does it work? Wow.
Okay, so what we have here are some heat lamps, and down here is a build unit, and we have nylon powder that is spread across this bed, and it builds up gradually in 800 micron layer, and as it's building up, this head here pulls across, and as it goes across it prints just like a printer that you'd know, an inkjet printer, and prints fusing agent. And where the fusing agent is, which is black, that takes the powder up to and above the melting temperature. And so you have molten pieces, which is your solidified part, and you have the white powder, which is just below the melting temperature, and then that keeps going in and keeps going until you've got your full build with parts. And here we have a build unit, which is a separate piece which you can wheel across for processing in another station.
So what opportunities are you getting with this technology?
Quite a few. It's a very flexible process. So not only are we using it to iterate prototypes very quickly and doing small batches, we can then ramp up with the same process and the same technology to get production parts out. So if you do a prototype, the materials and the properties you get from that prototype are going to be the same for the end part. So you can iterate very quickly.
So how creative are these machines allowing you to be?
Fully creative. The scope is massive, really. So anything you can think of shape-wise that fits within the volume. So the volume being 380 by 380 by 284, you can fit a part as big as that in there. There are no limitations effectively on shape and size. You could have multiple parts in there, multiple moving parts within the same part. Between us in our professional backgrounds, we've been using injection molding for many years, and it's really hard to get your head and the way you think away from injection molding, because you're always thinking about draft angles, about releasing, about side actions and things like that. But within 3D printing in this process, you need to almost change your mindset, forget about that, and design the parts that you want and not think about the process, and that gives you enormous freedom.
So now we've got the build unit in the processing station. This is actually a real build that we did over the weekend. We've already pulled some parts out. To get the parts out, you simply vacuum the powder up, and you can just rub off the loose powder, and that goes over there. Out of this loose powder, actually 80% of the powder out of there gets reused on subsequent builds, which is one of the reasons we chose the MultiJet Fusion process, because you can have such high reusability.
And does that save you a lot of money? Is the powder expensive?
Yes, I mean it is very expensive, but once you're up and running and kind of all the reservoirs are filled, then you're not actually using much new powder every time.
And then how long does a process like this and a whole build take?
So when it's actually in the machine printing, that can be up to 16 hours. And then once you wheel it into here, You can let it naturally cool, which is 42 hours, or you can do fast cool, which will save about half that time.
You can do it lights out as well.
Yes, one of the great advantages is we put it on a Friday, and it can be running over the weekend, and as we did this morning, we come in and it's ready to go, all cooled.
And just go really, really quickly, just for cameraman, look at the sizes of the parts, the variety. You've got small parts, large parts, such versatility.
Yeah, I mean, majority of parts are quite small, but we are also doing some larger parts like this. And you can see that's a pretty large part. And one of the advantages of the process is when it's built, you can see that all these parts will actually be inside there, nested, which is a great advantage over other processes as well.
Production is something that people wouldn't really think of alongside 3D printing. So I think it's changing in this area.
I think so. I think we're finding a niche with the products that we're making, which are sort of below the 1,000 product mark, which generally was a kind of marker to go into injection molding. But within that area of hundreds of parts in batches, so within our printer, within a volume, we can print, say, 500 of one of our parts in one batch. But of those 500, we may have 4 different types of that part, so we can print them all at the same time. So rather than doing a production run of you're stuck with 500 of that particular part,
Yes.
we'll do iterations of that to fit different things.
Oh, wow. So these aren't just for prototyping. It is production too.
From the processing unit, we then need to remove the rest of the powder. So we do that by sandblasting, and then we have to dye the parts black. And then we move on to our PowerShot S surfacing machine.
And this is from Matsuura as well.
Yes, yeah, we got this from Matsuura. And the important part of the surfacing machine is it turns our products from a functional part, which is this part here, and that is, you can see it's got a matte finish and it does scratch a bit easily. And then when it's been through the surfacing machine, you get a homogeneous surface, which is much tougher and much more used to the sort of consumer finish that people are used to.
Is this an essential part of the process then?
For us, yes. As doing consumer products, I think it's essential that people get the finish they would expect from a high quality part.
And you're happy with this machine and everything really that Matsuura have provided for you?
Yeah, I mean, it's incredible in the 2 months we've had it. You know, we've even grown in that time. So from moving from being dependent on outsourced parts to bringing it in-house, we don't have the supply issues we previously had. And also we're able to supply things against product manufacturers who may be produced in the Far East. And we've seen the supply chains being severely affected by COVID, and we've been able to carry on increasing our production while they've lost it.
So overall, are you glad in this investment?
Absolutely. I think we wish we could have done it sooner. It's given us lots more opportunity within the company. It's given us loads more ideas. Clients are coming to us knowing that we've had the machine and we can produce parts for them. It's just developing more avenues for us going forward.